thank you for joining me today for this presentation on radiation protection in the industrial sector. As Phil mentioned, I am Kathy Lawrenson and I am the Managing Director of McKavanagh Engineering Services Proprietary Limited. Before I start with my presentation today, I'd just like to encourage anyone that has joined the webinar that isn't currently a member of ARPS to consider joining. ARPS is a society with experts, full of experts in their respective fields in radiological protection, such as environmental, industrial, and of course the medical field. So I really encourage you to consider joining ARPS today. At the end of this presentation, if you have time, feel free to look around or navigate around the ARPS website and you'll find more details on the society. Okay, so without further ado, I'll kick off the presentation. Okay, McKavanagh Engineering Services Proprietary Limited, or MES for short. MES is a lot simpler to say. McKavanagh Engineering Services is a bit of a mouthful. So who are we? The company was founded in 1998 by Byron McKavanagh, hence the name. And Byron graduated from the University of Queensland in 1973 and completed a Master of Science in Applied Physics. He then went on to work at the CSIRO as a technical officer and later became a senior lecturer at Central Queensland University in Rockhampton. When Byron first started the company, his main focus was on the provision of training to radiation safety officers in industry and assisting such persons to comply with the legislation. So fast forward to 2023, the company's been around for a long time. Byron has now retired and he has happily retired. He retired about 5 years ago, in all honesty, and he's spending his time living his best life now, traveling around the countryside and just relaxing, and it's all very well deserved. So I am the proud owner of McKavanagh Engineering Services today, and I employ a small team of 6 people, which is nowhere near enough people that we need in order to manage the demand. So what do we do? I had to think about it when I was putting this list together, because in reality, the list of things that we do for our clients just seems to be endless. So in terms of services that we provide, this list is a semi-list. It's not a complete list. So first and foremost, we provide approved radiation safety training. So there's no nationally accredited course for radiation safety officer training in industry, and there's no nationally accredited course for use of particular types of radiation sources. So our courses are approved locally through the Queensland regulator. So a lot of the work that we do involves travelling around to our client mine sites or wherever the client may be, and delivering such training on site. Another one of the services that we provide is the supply of nucleonic instrumentation to clients. And in line with that comes the ultimate disposal, or in Queensland, as we say, relocation of sealed radioactive substances once they're either no longer required or the sealed radioactive substance has passed its recommended working life as set by its manufacturer. We carry out a lot of systems audits on site, and that helps the client feel comfortable that they're complying with the requirements of the legislation. We do a lot of site radiation surveys and inspections, so that involves the physical survey. So we're trudging around in wash plants and all sorts of glamorous places doing that sort of work. We formulate or put together security plans, transport security plans, and radiation safety and protection plans, which may sound simple, but all of those types of plans have to be specific to the type of radiation practice that is being carried out. So there's a lot of considerations that have to be taken into account when you're formulating those types of documents. We perform compliance assessments for our clients, again, to ensure that they maintain their compliance with the legislation in Queensland. And then some other things like white testing and analysis. We do installation, commissioning, repair, decommissioning. We do a significant amount of transport of radioactive substances. And in Queensland, unless that substance is an accepted package, the transporter has to have an individual transport license unless it's a company that holds a license for. Anyway, disposal of uranium and thorium compounds, which there's an awful lot of around the country because they're used widely in universities. So that's just a brief overview of some of the services that we provide. So where we are in Queensland, there are approximately 50 operating coal mines in Queensland and around 100 metalliferous mines. So they all range in size. They all have different size capacities, throughputs, etc. Geographically, Queensland is close to the largest developing markets in the world, and major mining related centres are Mackay, Townsville, Gladstone, Rockhampton and Mount Isa. So 90% of our work is carried out in Queensland and the remaining 10% is carried out in Papua New Guinea. So we operate almost exclusively in the state of Queensland, which is the second largest state in Australia. Our main facility is based in a small regional town near Brisbane. We have a local branch in Mackay. So our main facility is in a small town called Fernvale. And that facility consists of office space and 3 industrial size sheds. So a lot of our source processing occurs at our main facility. We have another facility that's based up in Mackay in central Queensland, and that is because Mackay is very close to the Bowen Basin, which I'll talk about a little bit more in a minute. So we travel frequently both by plane and road between both facilities. In the past, we have been involved in projects in other jurisdictions of Australia, such as the Northern Territory and in New South Wales. Due to a lack of suitably qualified people, we tend to refer such work when we can to other service providers in those jurisdictions. So wherever possible, if we have a request for work in another state, we will try and find somebody that does or that can provide the same type of services of us in that particular jurisdiction to offer those services. So we refer a lot of clients. Okay, the map that you can see on your screen at the moment shows operating coal mines located within the Bowen Basin. The Bowen Basin contains the largest coal reserves in Australia, and it covers an area of around 60,000 square kilometres. The Gladstone region is home to 2 large alumina refineries, and Rockhampton has a major magnesite mine and magnesium production plant. So this area of Queensland as a whole is a major mining hub. So you can see by looking at this screen, our location in Mackay puts us very close to a lot of these regions. There are a lot of metalliferous mines in other areas of Queensland, northwest Queensland, and far north Queensland, such as Cape Flattery and Weipa. So in all reality, we travel all over Queensland, and we travel all over Queensland extensively. So there's a lot of activity that's going on. Okay, so to help you understand why clients might actually look for our services, it may pay for me to explain what the regulatory requirements are in Queensland, because as we may or may not know, The legislation can vary considerably from state to state. So in Queensland, the possession and use of radiation sources is heavily regulated, and it's actually a good thing. It means an awful lot of work for us. So Radiation Health, which is a division of Queensland Health, administer and enforce the Radiation Safety Act that was introduced in Queensland in 1999. So the legislation consists of the Act, of course, the Queensland Radiation Safety Regulation that was reviewed in 2021, and the associated Queensland Radiation Safety Standards that were also reviewed in 2021. So in Queensland, a prescribed radiation source can only be in the possession of an individual or a company who holds a possession license, so a license to possess such a source. So in order to be granted a possession license, a radiation safety and protection plan must first be submitted and subsequently approved by the Chief Executive of Radiation Health. That plan, or the Radiation Safety and Protection Plan, or as we say, RSPP for short, must adequately describe the hazards that are associated with the particular radiation source that the licensee wishes to possess, and more importantly, how the licensee intends to manage such hazards. So what controls are they going to put into place? The possession licensee in Queensland must appoint a suitably qualified radiation safety officer. And under Section 37 of the Act, the functions of the radiation safety officer are specified. They include identifying whether radiation safety standards are being complied with, identify ways consistent with the Radiation Safety and Protection Plan of minimising radiation dose to persons both involved in the practice and persons that are not. Training about precautions to ensure dose is minimised. Reviewing the Radiation Safety and Protection Plan at specified intervals to ensure, that those provisions are being met. The report to the possession licensee, because the possession licensee must be kept aware of how effective the safety measures and controls are. So they must be kept aware of that at all times. The radiation safety officer advises the licensee of the results of a review, and reviews must be undertaken at specified intervals. It's generally every year. And the radiation safety officer needs to make recommendations about any changes that are required to ensure continued compliance. So having briefly shown what some of the requirements are in Queensland, it may help you understand why companies require our services, and particularly mining companies. Because in a mining environment, the person that is appointed as the radiation safety officer generally holds a primary role in a senior position that is totally unrelated to radiation safety. So this person could be a mechanical superintendent, or a planner, or electrical superintendent, or occupational hygiene superintendent. So the radiation safety officer position becomes secondary to their primary role. Not only that, a lot of mining companies these days operate on a fly-in, fly-out basis, where the appointed radiation safety officer doesn't live in the vicinity of the workplace. They may have 2 weeks off at a time. They may work 7 days on, 7 days off. They could, work 21 days off. And then have 2 weeks off. So from their perspective, at times it can be difficult to keep in touch with actually what's going on at the workplace. So what we did over the last 6 months was we contacted the majority of our clients and tried to identify what are the two main reasons that you use our services? And the number one reason was to ensure that compliance is maintained. So we assist the radiation safety officers to perform their functions so that they can report to the licensee that everything is as it should be. The second reason is because of the provision of training that we provide. And that could be in relation to specifics on a certain site. So what type of nucleonic instrumentation do you have? And we can tailor that training to be specific. A good thing about doing on-site training is that you can do hands-on practical, and that sort of thing becomes invaluable. It's much better than just training in a classroom environment. Okay, so what type of radiation sources are used? By far the most common in mining would be the good old density gauge. So density gauges are used widely for process control. So they make the wash plant or the processing plant run more efficiently. The sealed radioactive substances that are incorporated in sealed source apparatus or fixed industrial gauges is cesium-137. And as we know, cesium-137 is a gamma emitter, and it's used widely for its ability to see through or penetrate through a diverse range of materials. So any mine, depending on the size of that mine that has a wash plant or a processing plant, will have anywhere from 1 to 10. Some plants can have up to 100. It just depends on the size of the operation. But in terms of nucleonic instrumentation, density gauges would be by far the most common thing that you would find. Secondly, would be the bulk materials analyzers, particularly in coal. And they use them for coal blending verification of their product. But they used a californium source, so californium-252. And the measurement technique is prompt gamma neutron activation analysis, or PGNA. The picture that you see in front of you is the picture of an on-belt analyzer. So the coal travels through a tunnel, and the neutron source activates the coal, and the signal that is received by the detector are signature gamma rays. So there's a mixed feeling towards these types of analyzers. Some people swear by them and other people's aren't that fussed. One of the disadvantages of PGNA is the use of californium-252 because it has such a short half-life. So when purchasing a bulk materials analyzer, you're looking at, performing a source top-up every 2.5 years. So that becomes a very expensive exercise. They can be time intensive in terms of calibration and keeping them going. It can be argued, though, if you put the time into them and the money, that they are invaluable. I'm not even going to enter into that argument. It's outside of my pay grade. Okay. Another type of analyzer that you would see on site is an ash analyzer, and again, particularly in coal. Because we want to be able to determine the ash content. So substances or radioisotopes that are used in these applications are cesium-137 and americium-241. So it's a dual energy gamma gauge. So we know that cesium-137 emits 662 keV gamma rays and americium-241 emits 59.5 keV gamma rays. So the combination of these two allows for good determination of ash content in coal. In the metalliferous environment, we tend to see online or XRF multi-stream analyzers. So this is where a probe is actually sitting in the process stream. And these are like the PG&A high-end instrumentation. Some sites swear that they are critical to their process for determining elemental analysis. This particular application utilises a sealed radioactive substance as a source of X-rays, and it's plutonium-238. If we had all day to talk about it, I could discuss the issues that you have getting rid of plutonium-238 when it's no longer required, but don't have that much time today, so perhaps that's for another talk. All right, site laboratories. So a lot of sites have their own labs. So they could have benchtop XRF, they can have cabinet XRF, they can have geologists that run around with handheld XRF. So you see a lot of these on mine sites, regardless of whether it's coal or whether it's a metalliferous operation. So the instrumentation that I just showed you is the more common instrumentation that you would find. There are obviously, as new techniques become available, there is different types of instrumentation, but these are by far the most common that we come across in terms of what we see on client sites. So any type of nucleonic instrumentation that you have must be routinely inspected and surveyed. So that is a lot of the work that we do. Routine inspections must be carried out at specified intervals to ensure continued compliance. And the frequency and level of detail involved in the inspection regime will depend largely on the type of radiation source or substance that's being used and the environment in which it is installed or used. So some common items would be measurement of dose rates. So are they within acceptable limits, and does that particular piece of equipment continue to meet the requirements of the Queensland radiation safety standards? The shielding is intact. The radiation warning labels are clearly displayed. Looking at the overall condition of the radiation apparatus or the sealed source apparatus, and then any ancillary items that may impact the overall safety of the apparatus or the sealed source apparatus. So frequent inspections, and a lot of our clients do inspections on a 3-monthly or 6-monthly basis. Okay, I'd like to discuss now some of the interesting projects, briefly discuss some of the interesting projects that we have been involved in. And I'll start off with the very first major project that we were involved in, which was really quite exciting for me because I learnt an awful lot about how the world actually works by undertaking this project. Okay, so in 2013, we were contacted by a client they were in the possession of 40 sealed radioactive substances that were all past their recommended working life as set by the manufacturer. So anyone who is familiar with sealed radioactive substances, the recommended working life is the time frame, basically, that the manufacturer will guarantee the integrity of the source encapsulation under normal environmental or normal operating conditions. So for cesium-137, mostly, the recommended working life is 15 years. So this particular site wanted to get rid of these sources that were past their recommended working life. However, the gauges that they used were critical. So they were critical level gauges that could not be removed for any length of time from service. So what that meant was if they did, the whole place would have to shut down. And when you're talking about a plant of that size, to shut down for even 24 hours, you could be talking in the millions. So we sort of looked at the job and said, well, you know, how can we help the client without actually removing these particular gauges from site? So we performed an inspection on the source containers and realised that they were actually in really good condition. So we submitted an application to use or to continue to use the source containers for a certain amount of time. And we were to remove the redundant sealed radioactive substances from each gauge and replace them with new ones. So essentially, we changed the source capsules only. So what did that mean? That meant that all of the work had to be carried out on the client site. So that was nerve-wracking in itself. How were we going to keep people away? How were we going to, you know, communicate what was happening without making people panic? How were we actually going to perform the work and ensure that the exposure to ourselves and everybody else was going to be acceptable? So eventually it was decided on the work plan that we had put together. We designed and had built a portable hot cell facility where we could safely physically handle the sealed source capsules, and all work was carried out inside a 20-foot sea container. So we had the whole area barricaded to an area of 20 metres, which was overkill, but at least we felt comfortable that no one was going to come near us. The barricaded area was manned too, so I felt sorry for the guys that had to sort of stand there and hang around all day. But it made sure that access to the area was controlled. A site-wide memorandum was sent out explaining what we were going to do and why we were going to be there. We had to manufacture shielded lead pots with handles in order to transfer the source rods from the installation position down to the container where all the work was taking place. So this was probably the hardest or the most difficult aspect of the work, because all of those gauges were installed on platforms. So you had to climb up the ladder, and then you had to walk down 3 sets of stairs in order to bring them to the container where we could actually change the source capsules over. So at the end of the work, neither of us wanted to go anywhere near a gym for at least the next 12 months. Every single muscle in our bodies was aching. So that was probably the most difficult aspect of performing the work. We successfully removed all of the redundant capsules, and you can see down on the left-hand side, there's a picture of a capsule that's in excess of 20 years old. So it was in absolutely beautiful condition. Obviously leak-free, there was no issues whatsoever. It took us 6 12-hour days on site to get all of this done. And all of the sources were successfully relocated back to the manufacturer, who was QSA Global in the United States. So it probably took us about 6 months to plan all this and put it all together. But it was a really fantastic feeling when we achieved the objective. Okay, project number 2 occurred in December 2014. One of our very few jobs that we have done in another jurisdiction of Australia. So this was the largest single disposal of sealed radioactive substances used in industry that we've ever undertaken. And it probably wasn't until we were halfway through that we thought, wow, we may have bitten off more than we could chew here. The company that employed us to relocate or dispose of their radioactive substances wanted the work done 5 weeks before Christmas. It was wet season. In order to access the site, it's in excess of 700 kilometres of dirt road to access. So the temperatures at that time of the year in the Northern Territory are horrible. So there's extremely high humidity, 31 degrees C, you know, and a minimum of 28 degrees C. We had a couple of interactions with some feral buffalo on the way in, so that was very interesting. We had the side of one of the vehicles kicked by a feral buffalo, and that made sure that when we were travelling in, our top speed was 70 kilometres an hour. So it took us a long time to get there. So the project was the permanent relocation of 120 fixed gauges and 2 moisture gauges. So in order to bring all of the gauges back so that all sources could physically be verified and processed, we had to drive all the way from the Northern Territory back to our location in Fernvale. So the consignments needed to be separated in order to avoid a security aggregation. So we didn't want to be transporting security enhanced sources. We required approval in 2 jurisdictions in order to get this done. Because of the wet season and the time of when we visited site, we successfully arrived, but we couldn't get out. So we were stuck on site with 2 trucks full or loaded full of packages of industrial gauges, all bolted into crates that we could not get off site. Eventually, we obtained approval to put both of the trucks on a barge that were sent to Darwin. We had to wait in Darwin for 8 days for the trucks to arrive. When we eventually made it back to Fernvale in Queensland, it took us 12 weeks to download and process all of the sources. There was little information available on some of the sources, and one of the sources or gauges in particular was very difficult to identify the origin. So who was the original manufacturer? There was no detail on it. So that was particularly difficult to get rid of. But again, at the end, we achieved the objective and we managed to get the job done. So very excited about that one. Project number 3 in 2016. So we weren't involved initially with this, but we were involved at a later stage. So in late 2010, a cesium-137 source, so sealed radioactive substance, was found to be actively leaking during a compliance assessment. So these pictures show the make and model of the gauge that was involved in the incident. And the gauge was installed vertically on a pipe. The shutter mechanism itself consisted of a spring-loaded source rod that housed the sealed radioactive substance or the source capsule. So in order to open the shutter, you moved the source rod down, and in order to close the shutter, you moved the source rod upwards into the shielded position. So you can see quite clearly in the center picture there that the source shutter mechanism is spring-loaded. So that spring assists in keeping the shutter in the closed position. So from the original or the initial contamination event, 8 44-gallon drums of contaminated waste was generated from the cleanup activities that we weren't initially involved in. So handrails and other fixtures needed to be cut or removed from the plant because contamination was fixed and it couldn't be removed. It took 2 years for the planning and approvals to be in place. So there was dosimetry modelling, there was leachate testing and modelling that had to occur. All that was beyond our scope of expertise. However, others were involved that performed that work. The most difficult component of this was, again, the client wanted the work done in the middle of summer. We used the same methodology that we did for the first site removal of a source that we carried out. We decided that in order to best provide access control and perform the work, we should work in a 20-foot sea container. So it was extremely hot. It was the middle of summer in Queensland. We actually worked inside a space bag. So we lined the container with a ginormous space bag. So what that meant was that if there was any spread of contamination, that everything could basically be closed up within that bag. Excuse me. So the pictures that you see here, you can see me on the left practicing with the gauge in a 2-port closed loop glove box. We needed to make sure that the work could actually be carried out inside that glove box. And on the right-hand side, you can see a picture of a glove box that's actually sitting inside the space bag. And it was painted internally with carboline. And carboline is used routinely to decommission nuclear reactors. So we thought it was a good plan. All right. So again, it was extremely hot. We managed to successfully remove the source rod. However, we could not picture the source capsule. The dose rates were considerably high, so we just decided that we would put the rod inside the special form capsule or special form cylinder that was provided by QSA Global in order for us to successfully isolate that source. This is probably the most recent project that we've been involved in, and it's work in Papua New Guinea. So legislation was only introduced in Papua New Guinea in 2019. So the Papua New Guinea government introduced the Radiation Safety and Control Act in 2019 and the Radiation Safety and Control Regulation in 2021. So the implementation of the legislation has been a bit of a drawn-out process, and it's very difficult to understand the legislative processes because I'm used to the way that Queensland works, so it's taken me a little bit longer than perhaps it should have. But anyway, long story short, in December 2022, we successfully relocated 22 sealed radioactive substances that originated from fixed gauges, all past their recommended working life. Again, all work was carried out on site, utilising a portable hot cell. So we didn't send ours over there. We manufactured and sold one to the company that was almost the same as the one that we have. That was used. We would put up the back of the plant miles away from anyone, again in December, in the middle of summer. So it was horrendous. But we managed to get it done. So it's always a sense of achievement when you come across a project that seems difficult. And at the end of the day, you can manage to achieve it. So the challenges were, and there was a significant number of challenges, but the main ones were obtaining approval from the regulator. And that wasn't the regulator's fault. Please don't get me wrong. we were sort of trying to work out between us, you know, what we needed to have in place and how we were going to satisfy the regulators that we, number one, knew what we were doing, and that everything was going to pan out okay. So it took us 15 months from the date of application to receive official approval to attend site and undertake the work. Performing the work on site proved to be considerably difficult, again, because we were forced to work in really intense conditions. It was difficult to get lifting equipment in where we were, and most of these industrial gauges, for anyone that's ever worked with them, you know, the lightest one is about 45 kilos. Some of the ones that we were dealing with were 90 kilos. So, that, you know, there's no way that I can lift one of those, or even, you know, Peter can lift one of those. You just can't do it. The risk in terms of what we're doing here is greater for, you know, the manual handling of the gauges themselves, not the radiation exposure to a certain extent. So we managed to get the sources out and package them appropriately in approved .A containers. We packaged 4 containers up, and then they were stuck there. So we had all kinds of logistics issues. We had to barge the packages from site to Port Moresby, which, as you all know, is the capital of Papua New Guinea. Then, in order to fly them out, we had to fly each package out singularly. There were weight restrictions for the packages. So the weight restrictions were 50 kilos each. There were 4 packages in total, so that meant 4 separate flights out. So the tracking of the consignments was a bit of an issue. I had a couple of sleepless nights because I couldn't adequately locate where they were. I knew they were in transit somewhere, but it upset me greatly that I couldn't put my finger on exactly where they were. But eventually they arrived at their final destination, and it took 5 months for completion. So that was a real challenge. It was enjoyable to get to see the result at the end, though. It was great that we achieved that for the client, and therefore made their lives easier for getting rid of sources that they no longer needed and had no use for. And they did it in a safe and effective manner. Okay, so everyday challenges. These are the types of challenges that we face as a company. And the biggest challenge that we have is that we simply don't have enough qualified people. I'm getting a bit old now to be doing physical work of the magnitude that's required. So a significant amount of education and training is required for anybody that needs to or wants to work in this industry. And working, particularly in a mining environment when you're installing, removing gauges or commissioning or calibrating an analyzer, it's not particularly glamorous. And another challenge is the amount of travel that we need to undertake. So we need to travel very long distances and frequently. So a main issue that we have is obtaining people and getting them trained and skilled with the appropriate skills. So it's a real issue for us. You know, what happens when the likes of myself and people like me are gone? Who's going to do these roles? So it's important that we have somebody that can, you know, take over from doing that. Okay, that's it for my presentation. Thank you very much for your time and attention, and I'm happy to take any questions that you may have